All right, so this is Unit 8, Day 4 notes. These are the objectives. There are quite a few objectives. Some of these problems and solving these problems can get very lengthy, but we are going to muster through and have the strength to finish the problem and do what we got to do to make it so that it's following the rules and getting the correct answer. In order to do that, you have to be patient and you really have to do the right thing. Don't try to skip steps. Don't try to make it easy on yourself in some situations or get tired, because this is like a marathon. It takes time to understand, and definitely takes practice. So I know that you can do this. If I can do it, anyone can. Believe it or not, I can do it. You can do it too. It just takes a lot of work and practice, and I know that you can do this. All right, so these are objectives here. Moving forward, let's kind of start where we ended last notes, and that is kind of simplifying and breaking down some of these things. What I would do first is since I'm multiplying, I would just start breaking things down. 9 times 3 is 27, and then I break that down into 3 times 3. So basically all of these our situation here, and it looks like it's a fourth root, so we need 1, 2, 3, 4 in this case. 4 threes come out one time. Your answer is just 3. Okay, so knowing the root is important. I would break it down before I even start multiplying. Again, you can multiply, it's fine. This one is 4 times 4, 4 times 2, and I already see 3 fours. 1, 2, 3 fours. The 2 is left by itself. I would bring that out. So this becomes 4 on the outside, cube root of 2, it's left over inside. There are no partners that go with it. So you don't have to keep going. If you can see the 4 threes, bring them out, and then you're done, okay? Oh, we didn't even have to do that, but that's okay. All right, so same thing here. I have 4 and 5. I also have another 4 and 2, 2 and 2, 2 and 2, okay? So the gatekeeper here is 5. 1, 2, 3, 4, 5 twos. So I'm going to bring out one time. Bring that 2 out, and then the 5th root of 5 is left over inside there. You have to have 5 at the same thing in order for it to come out one time. In this case, you only have 1 5, so we have to leave it in. 5 doesn't break down anymore. Now the B's, I would add those 2 exponents. 2 and 5 is 5. If you have the 5th root of 5, b to the 5th, you know, as earlier you could have said, if it's raised to the 5th and it has a 5th root, basically those cancel each other out. It will just become b on the outside. So your answer here would be 2b and then the 5th root of 5. That is our answer there. Okay. All right, so let's move down to this one. Our gatekeeper root is 4. I would start by breaking down 4 times 3. We know that's 2 times 2. And we know that's also 2 times 2. So with this particular one, 1, 2, 3, 4, 4 twos, 2 comes out one time. 3 is left on the inside. There's nothing we can do with that one. The W's, I would add the exponents. 9 plus 5 is 14, so W to the 14th. We know that we're going to be dividing because we have the root, okay? So it's the 4th root, basically, of W to the 14th. We can divide the 2. How many times is 4 going to 14? Looks like 3. That's 12. 2 is left on the inside. 3 goes outside. So 3 W's come out. W cubed. And then how many 2 W's stay inside? So now all the outside numbers I'm going to put together. 2W cubed. And then all the inside numbers. 3W squared there. Okay, so that will be our answer for that particular one. Now there are going to be some that are just so long that I have to grab a piece of paper. So I have like a couple of pieces of paper here just in case, lined paper, so that I can solve the problem. If it gets too much and it can't really fit here, I'll write it on a separate sheet of paper and finish it that way. So let's go ahead and begin here. This is kind of like a new situation that's happening. for now. And we're just starting this multiplication. And clearly, once they start introducing it, we're going to be doing that. And this can get pretty lengthy. So I will probably move into another sheet of paper once we start doing this. Really, once we get down here to some of these get pretty long. All right, so we're going to multiply the square root of 6 times both inside. We're going to distribute. So if it's on the inside, if it's both, they're both inside a root, then you can multiply the numbers. If they're one's on the outside and one's on the inside, you just have to kind of put them next to each other, and I'll show you what I mean. So this is the square root of 6 times 6 on the outside. It just becomes 6 times the square root of 6. There's nothing you can do there. Minus, then we have the square root of 6 times the square root of 5. And of course, they're both inside the square root, so you can multiply 6 times 5, we get 30. And as we said earlier, the square root of 30 does not simplify. If you had to simplify, you could. You cannot put those together. You can't make that like 30 minus 6. You cannot do that because what is in the square root has to be the same in order to combine them. Okay, so we can't do anything. We kind of have to leave it separate. I know it looks weird, but that's just what our answer is going to be. All right, so let's move here. So what you're going to be doing here is you can multiply the numbers on the inside of the square root, and then the number on the outside has to stay. So 7 goes here. I'm going to multiply 15 times 5. All right, that is 75. Minus, and then 3 times the square root of 5. We're just going to put them next to each other. We do have to kind of simplify that. 25 is in there, it looks like. And probably 3, sorry, not 7, 3, okay, and of course the 7 is still on the outside, and the square root of 25 is 5, so 7 times 5, okay, this comes out to be 5, and then the square root of 3 is still left over inside. I'm leaving this the same, we're not doing anything with that. And then 7 times 5, of course, is 35 times the square root of 3 minus 3 times the square root of 5. This is your answer. Why can't we put those together? Because they don't have the same square root. Okay? Square root has to be the same in order for us to combine that 35 minus 3. You can't do that because this one has square root of 3, this one has square root of 5. We have to leave it like this. Looks weird, but you'll get used to it. Okay? All right, but we did have to simplify over here. All right, so 9 times the square root of 3 times the square root of times the square root of 6, and then 9 times the square root of 3 times square root of 14. The number's on the inside, so that 9 stays on the outside. We're multiplying 3 times 6, that becomes 18. Minus, same thing, 9 stays on the outside. We're multiplying 14 times 3, and we get 42, square root of 42. Okay, we are going to try to simplify as best we can. This becomes 9 and 2, and we know the square root of 9 is 3. So basically 9 on the outside, 3 on the outside, and then the square root of 2 is left on the inside. Okay, 42, what does 42 have in it? It looks like 7 and 6, square root of 7, square root of 6, neither one of those simplify. So there's nothing you really can do with 42. Okay, 9 times 3, it doesn't have any square roots in it, perfect square. Okay, if we broke it down to 7 times 6, it wouldn't change anything because neither 7 nor 6 is a square root, so I'm leaving it 42. 9 times 3 becomes 27, so this becomes 27 square root of 2 minus 9 times the square root of 42. This is your answer. Cannot combine them, they're unlike. All right, so this situation is you're squaring it. So you are taking this entire situation and squaring it. So you need to FOIL. FOIL is basically multiplying the first term, and we've done it before. You should definitely be familiar. This times this is going to be 2 times 2 on the outside, and then the square root of x times the square root of x. You should know if you have 2 of the same, so we have the square root of x times the square root of x. If you have the same exact number, you're squaring it into radicals, it just becomes that number on the outside. So it's not x squared. It's basically the square root of x times the square root of x becomes the square root of x squared. We know that these two kind of cancel each other out. That's why it becomes x. Okay, two radicals multiplied by each other and they're exactly the same becomes whatever's on the inside outside. So that's why that became 4x. So 2 times 2 is 4, and then the x square root times square root of x times square root of x became just x. Now we have to multiply this times this. So 2 is on the outside, and then 2, the square root of 2x is on the inside. Because that one's an x and that one's a 2. We put them together. Now let's go to these. This becomes 2 square root of 2x. Okay. Same thing, 2, and then square root of 2x. And then here, square root of 2 times the square root of 2. Of course, it's the same thing on the outside. So whatever, square root of 2, square root of 2, square root of 4, and square root of 4 is 2. So this is just 2 on the outside. So if you multiply 2 square roots by each other, you know you're going to get whatever's on the inside outside. And that's what happened there. Okay? Let's combine these two middle terms. So 4x plus 4, 2 plus 2 is 4, square root of 2x plus 2. That is your answer. Okay. So yes, you have to do the work. Don't just try to skip it. Okay. You have to do the work. You have to do the harder thing, I guess you could say. Okay. So let's do this one. 3 times the square root of x times 3 times the square root of x. That becomes 9. And then the square root of x times square root of x is just x. 9x. You should know. They multiply a square root times the same exact square root. It gets whatever's on the inside outside. And then it's 3 times the square root of x times the square root of 3. This becomes plus 3 square root of 3x. This one is going to be, basically that's a -1. -1 times 3 is -3 times the square root of 3x. -1 times this becomes negative, and then the square root of 3 times square root of 3 is just 3. Okay? Multiplying square root of 3 times square root of 3 just became 3, and then the -1 made it negative. All right, as you see here, the middle two numbers, you can combine them because they are like terms. And one is positive, one is negative. You know, they look like they cancel each other out. So this just becomes 9x minus 3 is your answer. Okay. Recognizing those takes a little time, but with effort, time and effort, you can do it. You can do it. You can do anything. All right, so write in simplified radical form with at most one radical. Assume that any variables represent positive real numbers. Now for this one, I would definitely just I would turn it into exponential. So you remember how if you change this into 4/6 because the radical, this root is the denominator, okay, over y to the 1/2. No root there, but it's a 2, so 1/2. And then just subtract those two, okay? Subtract 4/6, so this becomes y to the 4/6 minus 1/2, okay? So I can put that in my calculator. 4/6 minus 1 divided by 2. That backwards L. I'm pushing this button instead of divide so it can give my answer as a fraction. So my fraction answer would be y to the 1/6. And then I change this back into radical. 6 roots of y to the 1 power. That is how I get my answer there. Okay. So it makes it easier just to change them into the fractions, subtract those fractions, and then whatever you get here, just put it back into radical form. And they want the answer in radical form. So that is the easiest way to kind of do that. Okay. Same thing here. I would change it into fractions. This becomes 2/7. This, of course, becomes w to the 1/2. Add those two because you're multiplying. I would add 2/7 plus 1/2. So 2 divided by 7 plus 1 divided by 2. Okay, my calculator. Push enter, and I get 11/4. So w to 11, 14. So the 14th root of w to the 11th is my answer for my radical. And that is in earlier lessons, changing exponential to radical form and radical to exponential form. So going back and forth between that. Remember, earlier lessons are important. If you don't know how to do those, it's a ladder. It's definitely a ladder. They build on each other. Okay. For these, I would divide the numbers, 75 divided by 3, see what happens there, because this is the same thing as the square root of 75 divided by 3. So just divide those two numbers, 75 divided by 3, hopefully it gives you 25. Okay, 75 divided by 3 gave us 25, so this becomes the square root of 25, which is 5. Okay, let's see what 78 divided by 6 gives us. So 78, I usually use this right here. 78 divided by 6 is 13. So this particular thing, once you simplify it, you have 78 divided by 6, you get the square root of 13. So there's nothing you can really do with that. That's as simple as it's going to get. All right. All right, so let's look at this one. Although there's no star there, I'll put 1 because I do kind of want to look at it. This seems to be fine, but the only thing you have to do is really simplify here, and then there's a little something else you got to do after that. So let's simplify. Let's take out the perfect square there. We should know that with 8, okay, 8 becomes basically the square root of 4 times the square root of 2, and the square root of 4 is 2. So this becomes 2 times the square root of 2. So instead of 8, we're going to have 2 times the square root of 2 plus 16 over 2. I left everything. So I've changed 8 to 2 times the square root of 2 because we split it up. Square root of 4 is 2. It came outside. Square root of 2 is left alone. There's not 2 of them, so we can't do anything with it. That's what that becomes. Now, if these 3 outside numbers, we are not worried about this inside number right now. If these 3 outside numbers can be divided if they have a something that is the same that can divide into all of them, you should. Only the 3 outside numbers, we are not worried about that number. Okay, I'm going to divide 2 by all of these because 2 is divisible into all of them. We can simplify them. 2 divided by 2 becomes 1, so this now becomes 1 times the square root of 2. 16 divided by 2 is 8, and 4 divided by 2 is 4. Now, it may look like you might, 8 divided by 4, you cannot do that. All 3 of them have to be divisible by the same number. And this is a 1. 1, 4, and 8 it can use 1, but it wouldn't change anything. You cannot just do these 2. I guess you could, but it would be like separating them. But I'm sure this is what they kind of want you to see. Okay, you could technically simplify this a little bit more by kind of breaking it up. You can make it the square root of 2 over 4 plus the 8 over 4. Okay, so you could break this up as well and make this the square root of 2 over 4 plus, and this 8 divided by 4 is 2, so this will just be 2. Okay, this can also be, I'm not sure what Alex is asking you to do, but you could break that up to be that as well. I'm pretty sure Alex is probably going to be leaning towards this situation, but then you'd have to break it up into 2 separate fractions like that. Okay, you could have done that up here actually. Could have broke this up and that up, and then just did it that way. Or this up and that up. Okay, so this is kind of what they want here. All right, so let's move to this one. Same thought process. What divides into all 3 of these? We're not worried about this. What divides into those 3? Looks like 5. 5, 5, and 5. So this becomes -6 plus 1 times the square root of 2 over 7. Okay, and then this doesn't even simplify at all. So you'd leave it kind of like right here. And that's where I was in my thought process here. But you could actually do this if you split them up. And this one did simplify a little bit more. But you have to split them up. That 4 has to stay under there because it doesn't simplify with that, but it does simplify with that. So this could be your answer. But this one, it won't simplify either way. You just leave it this way. Here, we'd have to go ahead and simplify that 24. Can we take anything out of 24? It looks like 4. So if the square root of 4 and the square root of 6, square root of 4 becomes 2. So this becomes 8 minus 2 square root of 6 over 12. Again, these 3 can simplify. What can I simplify? I can divide everything by 2. This becomes 4 minus 1 square root of 6 over 6, okay? And again, I can keep going here because 4 and 6 kind of simplify a little bit. And I can make it like this if I wanted to. I can split those up. And this kind of simplifies a little bit more and it becomes 2 over 3. So this will become 2 over 3 minus the square root of 6 over 6. Now, I'm not sure how far Alex wants you to go. If it wants you to leave it like this or continue here, okay? Depends. But whatever they're asking you for, if they want that number here just left this way, that's fine. But you also could split up that 6 and simplify even farther if you wanted to, okay? All right, so rationalizing denominators is important. When you're moving forward, your answer is not supposed to have a radical at the bottom of a fraction. That just can't be your answer. So if your answer has a radical at the bottom of a fraction, then you know that you have some more work to do, okay? So in this case, we can't simplify these two because one is in a radical and one is not. But in order to get rid of the bottom radical, we have to do something in order to make it so that it kind of fits better with the situation, okay? So what we're going to do is I would take the square root of 10 and double it, because we know that the square root of 10 times square root of 10 becomes 10 on the outside, and then it won't have a radical anymore. But if you do something at the bottom of a fraction, you have to do that same situation at the top. So essentially, you're not really changing anything because the square root of 10 times square root of 10 is 1. You're basically multiplying this situation by 1, which doesn't change the value, but it does change what it looks like. So I'm looking at the bottom. What can I multiply here to get rid of this radical? And that said the square root of 10, but if I do it at the bottom, I have to do it at the top, which makes this essentially 1 that I'm multiplying by, okay? So what happens here? Square root of 10, square root of 10 becomes just positive 10. And at the top, it becomes 6 times the square root of 10, okay? So I just multiplied these straight across. I know the square root of 10 square root of 10 is just 10 on the outside. 6 times square root of 10 square root of 6 times square root of 10. Now I can simplify this by dividing by 2. I'm just the outside, not the inside. Just the two numbers on the outside. I'm dividing by 2. I'm simplifying, and that becomes 3 times the square root of 10 over 5. And now I'm done. I can't simplify these two. One is inside, one is outside. Okay? And this is, I'm not expecting this to be easy, but it's something where you have, what is something you have to do. All right, same situation here. I'm going to multiply both top and bottom by the square root of 7 because I know the square root of 7 and square root of 7 becomes 7 on the outside. Okay? 7 on the outside. And the square root of 5 times the square root of 7 is actually 35 on the inside of my square root. And now I'm done. I can't simplify this. And there's no radical at the bottom. That's how I know I'm done. That's how I know that's my answer. If there's no radical at the bottom and I can't simplify anything going on, then I'm done. I can have this as an answer. It looks ugly, but it's just that can be an answer of mine because I did do the correct procedure, and now there's no radical at the bottom. Let's go here. There's a radical at the bottom. How do we know? Because this looks like this in reality. Okay, I'm going to multiply both top and bottom by 14. Square root of 14. Okay, this together, the same exact radical just becomes whatever numbers on the outside. And then up top, it becomes 1 square root of 140. Now, can I simplify that? Maybe. I can try to simplify 140. So 140, I divide that by 2. See what that happens. So what I'm doing is taking 140 and kind of breaking it down a little bit. So 2 times 70. And then 70 divided by 2 is 35. So 2 times 35, and that's 5 times 7. Okay. I broke all of those down. And I look, there's 2 2s in there. I can take out a 2. 5 times 7 is 35. That's all I can do. So if I took out a 2, square root of 35, because 5 times 7 is left over, that's 35 over 14. Now I can divide both top and bottom outside numbers only by 2 because they do simplify. So this becomes 1 times the square root of 35 over 7. Okay, this is my answer once I have simplified everything. And again, this is not the only way to do it. Alex may show you a different way. You have multiple ways to solve all answers. That's why math is hard, I think. Moving forward into mathematics is hard because you have multiple ways to solve the same answer. Same thing as walking to the parking lot. There's multiple ways to get to the parking lot. You end in the same place, but you just got there differently. Okay? All right. Let's move here into the back of page, it's on page 4 on the notes. You will now, same thing, split this up. I'm going to multiply top and bottom by the square root of 6, okay? So now I'll get 6 at the bottom, top, square root of 30. You should know square root of 30 does not simplify. And then 6 at the bottom means that we don't have a radical anymore, okay? Same situation here. I'm going to multiply top and bottom by the square root of 7y because again, I'm trying to get rid of this 7y. If I double it, it becomes itself on the outside. What's on the top now becomes the square root of 21y. Can I simplify that? Doesn't look like it. Can I cancel these out? No, one's inside the square root, one is outside the square root. Can't cancel them out, okay? Now, the same kind of principles apply to these type of problems, but they're a little different. And you have to be able to recognize, first and foremost, you cannot have a square root at the bottom of a fraction. So that's where the kind of rationale behind it comes in. But we're trying to get rid of that square root at the bottom of a fraction. So I'm going to go ahead and write that down here. -3, and then we have 5, -2, square root of 3. Okay, so this is our problem. I'm writing it here so I can have a little bit more room. Now, this situation that you're going to use is called a conjugate. And in order to get rid of this, you're going to have to multiply by this conjugate, the conjugate of this number. So if you have 5 minus 2 times the square root of 3, the conjugate is going to be 5 plus 2 square root of 3, okay? And you're going to see this in Alice, you're going to see this in your notes. This is just what you use, and you'll see why you use it, because once you use the conjugate, the radical goes away, okay? And that's why you're using the conjugate. But if you have to multiply by the conjugate, whatever you multiply by the bottom, you have to multiply the same situation by the top, okay? So we're multiplying this top and bottom by the same conjugate of whatever we had here. So let's, first and foremost, let's try this bottom one. 5 times 5, we have to FOIL it. 5 times 5 becomes, I'm going to turn this light off. I think it's giving me a little glare. Okay. 5 times 5 is 25. So this is 25 here. And then 5 times 2 times the square root of 3 is going to give you 10 square root of 3. And this one here, -2 times square root of 3 times 5 is going to be -10 square root of 3. And then this situation here is going to give you -4. Okay, -2 times 2 is -4. And then the square root of 3 times the square root of 3, what do we say that about that? Square root of 3 times the square root of 3 becomes just 3 on the outside. 2 of the same square roots multiplied by each other is just 3 on the outside. And then if you come down here, again, we're going to do the top in a minute. We're going to do the top, but I wanted to kind of finish this off. So 4 times 3 became 12. And as you see, these this 10 and -10, 10 times square root of 3, -10 times square root of 3, guess what? It cancels each other out. That's kind of why you're doing this, because now the square root is canceled out from the bottom. So basically now you only have 25 minus 12, okay? 25 minus 12 gives you 13. So at the bottom, guess what? 13, no more radicals. And that is why you're doing it, okay? And at the top, what you're going to do here is distribute. -3 times 5 is -15. -3 times this situation. 2 times square root of 3 becomes negative 6 square root of 3. So negative 15, negative 6 square root of 3 comes down. Is there anything we can do with these outside numbers? Doesn't look like anything goes into all 3 of those. 13 is prime. So this right here is going to be the answer. Okay, again, it may look a little crazy, but that's just how you're going to solve those problems. You're just going to have to take your time. And the conjugates, they get easier if you do them more and more often. Okay. All right. Let's look back at the next problem. So we did solve this problem. Okay. We solved this on paper. Let's look back at this problem. Same type of situation is going to go in there, and we can write that down as well. This one will be 3 over 7 plus 2 square root of w. Okay. And again, conjugate of 7 plus 2 square root of w is 7 minus 2 square root of w. And then if you multiply by the bottom, you have to multiply the same number by the top. Okay. And these two are, you're going to FOIL. 7 times 7 is 49. Okay. 7 times negative 2 square root of w is going to be negative 14 square root of w. This one will give you positive 14 square root of w. And of course, the 2 times the square root of w. So 2 times 2 is 4, minus 4 because it's negative 2. 2 times negative 2 is negative 4. And then square root of w and the square root of w become just w on the outside. Okay? And again, we'll do the top later. Let's kind of get through this bottom one before we figure this out. We know that negative 14w and positive 14w kind of cancel out. 49 minus 4w, you cannot put those together because one has a w and one doesn't. They're unlike terms. Okay. Then we're going to multiply 3 times 7, that's 21. And then 3 times negative 2 square root of w is going to be negative 6 square root of w. So 21 negative 6 square root of w is at the top, no square root at the bottom. This is actually your answer. Yes, it looks a mess. It looks ugly, but that is just how the cookie crumbles at times, okay? When they're put together by a minus, there's no way, even if this is just a w, you can't just cancel those out, okay? Because they're, it basically is married. I'd like to say married, okay? So this is going to be your answer. And the why this can be your answer is because there's no square root at the bottom of a fraction. Okay? Or cube root or root of any kind at the bottom of that fraction. All right, so we did finish those two. Let's look at this particular problem here and why, how we'll solve that. Now remember, there cannot be any type of root at the bottom of a fraction. And in this case, okay, we have 1 3. All right, we do have 1 3 inside our cube root. We need how many more 3s? We need 2 more 3s in order for this to come out, because you remember there has to be 3 of the same number in order for it to come out one time. What I'm going to do is go ahead and add those 2 3s. Okay, I can say 9 here, but it's going to be 2 more 3s that I need in order for it to come out, because I already have 1. Okay, that's actually a 3. I don't want you to think it's 2. Okay, but if I do that, I'm going to have to add 2 more 3s at the top there. Okay, so now 1, 2, 3 3s come out one time. At the bottom of this fraction is just 1 3, and up here there's 7 on the outside. What will 3 times 3 become 9? But it's the cube root of 9. So now these two can't simplify. This 3, you can't simplify this 9 because it's inside the radical. This is not. This is just your answer. There's nothing you can do after that. Once the radical's gone at the bottom, that can be your actual answer. Okay, so remember what your purpose is in these situations. All right, so the 4th root here, a 5, remember that 27 is 3 times 3 times 3. That's what it looks like. And I'm trying to basically get rid of, I'll break this down into 2. So there's a 4th root at the top, and there's a 4th root at the bottom. And remember what we're trying to do. We can't have a root at the bottom. So how many more 3s do I need? If I already have 3, I wrote 27 down, 3 times 3 times 3. I only need 1 more 3. So all I need here is 1 more 3. But if I have to add 1 more 3 there, I have to add 1 more 3 at the top. So here, now I have 4 3s that can come out 1 time at the bottom of the fraction. That's what I'm going to do. And at the top, I'll have the 4th root of 5 times 3, which is 15. Really nothing I can do there, but now that the root is gone at the bottom, that can actually be my answer there. Okay? So we are steadily getting through this. Not easy, I know, but still, once you follow your rules, you can solve these problems. Okay, let's go here. And the 4th root of 64. Okay, I don't know. For some reason I feel like it's even, but let's see. 4th root. Okay, 4th root of 64. Okay, so it doesn't really come out to be anything perfect, but we'll see. How many, let me break this down first to see what I need. 8 times 8 is 64, and this is 4 times 2, and that's 2 times 2, and this one is 4 times 2, and this one is 2 times 2. Okay, so 1, 2, 3, 4 2's come out 1 time. So in this case, I have a 4th root of 5 at the top, and I know that 1 2 came out, and now I have how many left over? 2 2's, it looks like, inside. Okay, so that 2 that came out is not the problem. We're okay with this. We can have that 2 on the outside. What we have an issue with are these 2 left over 2's. We cannot have them in a 4th root. So what we're going to do in order to get our answer here is we need 2 more 2's at the bottom. But if we have to add the 2 more 2's there, we have to add the 2 2's up here. Okay, it has to be the same, whatever this is. We just need 2 more 2's. We're okay with this 2 on the outside. It's a whole number, but the root at the bottom cannot be there. So we're going to add 2. We have 2 2's. We need 2 more for enable for those 2 2's to come out. So we already have, I'm going to bring down here, we already have a 2 at the bottom. Now that we have 2 more 2's, another 2 can come out. Okay, sorry. Another 2 can come out. And at the top here, we'll have 5 times 2 times 2. And that is 5 times 2 is 10, times 2 is 20. 20 up here. Okay, so this now becomes 4th root of 20 over 4, because 2 times 2 became 4. And you're done. You cannot simplify these 2. One is in a root, one is not in a root. Now that the root is gone from the bottom, that can definitely be our answer. If we could simplify here, we can't, because there's not 4 of anything in there. We know that's a 5 and a 2 and a 2. Okay, so that is our answer. All right. So I don't expect, again, this to be simple, but you got to do the work. Okay. All right. So we are on page 5 now, and we are going to just move right along. Again, what is wrong here? What is the problem here? We cannot have a root at the bottom. Okay. Can't have any roots at the bottom. So we're going to do our best to change that. So what do we have to multiply? First and foremost, we might be able to take a couple of those little x's out. But we know that 3, in this case, so for the 3, we know that we need 3 more 3's. Okay? We need 3 more 3's in order for it to share with this 3. I'm going to turn this back on because okay, good. All right? So then you can kind of see it a little better, a little light. All right, so we need 3 more 3's. We have 1. We need, our root is 4. Our gatekeeper is 4. 1, 2, 3, 4. But with the x to the 9th, okay, x to the 9th, what would we have, how many x's do you think we'd have to add to make that divisible by 4? Okay, so in this case, 9 is not divisible by 4. 8 is, but 9 is not. So what do we have to add to 9 to make it 8? 4 times 2 is 8. 4 times 3 is 12. How can we make this 9, 12? Add 10, 11, 12. Add 3 more x's to it. So if we add x to the 3rd involved in that, 9 plus 3 is 12, then that'll be divisible by 4, and it can come out nice and easy. Okay? So if we did all that at the bottom, guess what we have to do at the top? Same thing. Okay? So when I do that, okay, this becomes 1, 2, 3, 4. 4 of them come out once. So we know at the bottom this is just going to have a 3. And this x now becomes x to the 12th. We can divide that by 4, and that becomes x cubed. Okay? Now at the top, it's a huge mess, but we still have to do it. 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. Times 2, 27 times 2 is 54. So at the top, all inside have to multiply by each other. This becomes 54 on the inside. X cubed, y cubed. Again, we have to set them next to each other. They do not have the same bases. We can't add. We just have to kind of put them next to each other. So this is all inside of 4th root. Nothing can come out. And then we have this only on the bottom, and we want that because we do not have a root at the bottom, but we can't simplify anything, even if that's the same base, because this is in a root, this is not. So this is your answer. Okay, got to know your rules. Got to know your rules. All right. So let's look at the next one with the star. So 125, I want to say is 5 times 5 times 5. Okay. So here we have 3 5s in here. We have 5 times 5 times 5, okay? And in order, this is our 4th root, so we need what? 1 more 5. So we know we need 1 more 5 at the bottom. We're trying to get rid of this root at the bottom. And what would make this 7 divisible by 4 perfectly? It would be 8. 8 divided by 4 is 2, so if we have to add 1 more z there. We already have 7. If we added 1 more, z to the 8. So now we have to do the same thing up here. 5 times z. Okay. So now we'll have 1, 2, 3, 4, 5s. They can come out one time. And then z looks like to the 8th divided by 4 becomes z squared. Okay, so we have the bottom situation going on here. Top 5, and we can't, this is in a 4th root, this is not. So this 2w cubed is on the outside. The 4th root of 5z is just going to be sitting right next to it. Okay, there's not, you cannot combine those two. You can't simplify because one is in a root, one is not. So there's nothing you can really do here. This is your answer because you know you do not have a root anymore at the bottom. So now that can be an answer. Okay, that's your purpose. Knowing your purpose is important, because then you're not just doing anything. All right, so now we're moving into another like kind of place, okay? If you have a square, so in this situation, it says solve for the variable, okay, where there's a real number, they want real numbers. If there's more than one solution, separate them with commas. If there's no solution, say no solution. If you have a square root in this situation, an even, it cannot have a negative number, okay? If you had a square root of negative something, you know that would be no solution. So in this case, square root equal or negative, no solution. Okay. Here, square root, okay, in order to get rid, so now we can solve this because it's a square root equal to 15. To solve this square, to get rid of the square root, because we want u by itself, we square it, okay? So basically, you're trying, the opposite of a square root is a square, We're getting rid of that square root. Now we'll have the square root of a square is just whatever's on the inside is you. And then we'll have 15 squared, and that'll be 225. So your answer here is going to be 225. And to be honest with you, when you take the square, when you take this squared and both sides, okay, your answer 225, that's going to be just your answer. Okay. There are certain times when the positive and negative come into play. Actually, let me go ahead and check that real quick. Hold on. All right, so I checked that, and yes, that's your answer to 25 there. Just to make sure that you're not having, there's a couple ones when you're going to have to, and that's coming in a little later. Maybe on the back, yeah, on the back is where you're going to have to, and I'll show you that in a minute, okay? So here is a little bit more involved because you have all this little extra stuff. It's almost, you handle this almost similar, almost similar as the absolute value. Try to get that square root by itself. So let's get rid of this number. We're going to add 3 to both sides. And we have the square root of b minus 14 equals 5 plus 3 is 8, okay? So now that we have the square root, in order to get rid of a square root, you have to what? Square it. But if you square one side, you got to square the other side, okay? Or of the equal sign. And usually if I see that equal sign, I want to put a little line there. Now try to do something on this side, I have to do it on that side. So now it becomes b minus 14 equals 8 squared, which is 64. And then we can solve this just like we would solve any other equation. This now becomes b equals 64 plus 14, that's 78. 78 is your answer there for B. Okay. So, same situation here. We want to get that radical by itself. This is an equation, so I usually will put a little line there. I'm going to subtract 12 from both sides. And I get the square root of y minus 5 equals negative 5 here. Now, if you have a square root, just like we said up here, a square root equal to a negative number, it's going to be no solution, okay? So before you start going through and doing the whole problem, make sure you're understanding square root equal to a negative. It doesn't matter how big this is. If it's a square root equal to a negative, it's no solution. Don't even go any further, okay? Don't want you to waste your time or effort. You have enough time and effort being used in other things. So square root equal to a negative number, no solution. Okay. Let's turn this over to the back. We're just going to do 3 on this backhand side, and they're very, very similar. So you can definitely get these all, the top 3 are very similar to each other. So take time to practice, okay? For this one, again, you're getting the square root on the side by itself. So we have this extra 4 here. I'm going to subtract 4 from both sides of my equal sign. We're going to cancel that out. This becomes the square root of 3x plus 12 equals, again, negative 3. Square root equal to a negative number, no solution. Okay. And in this case, we won't continue on. Square root equal to a negative. Let's kind of try this one too. Although no star on it, it's still, I want to kind of get to solving these. This particular problem, I'd add 1 to both sides and get the square root by itself. So this is the square root of 4y plus 16 equals, and this is 1 plus 1 is 2. Okay, so we have a 2 there. So now it's equal to a positive number, which is true. So I'm going to square it to get rid of the square root. Okay, so it becomes 4y plus 16, because remember the square root and the square kind of cancel each other out. So 4y plus 16 just comes right on down. 2 squared is 4. And then I'd solve it just like I'd solve a regular equation. Subtract 16 from both sides. This becomes negative 12. And then 4y, divide by 4 on both sides. For your y is going to be equal to negative 3. Okay? So that's fine. So the answer can be negative. This is not no solution. The answer can be negative, but you cannot have a square root equal to a negative number. Once you have that square root equal to negative, no solution. But if you have the answer is negative 3, that is fine. Your answer can be fine as a -3, but it cannot have a square root equal to -3. Okay. All right, so finally, once you get down here, believe it or not, these are much easier than these ones up here. And once we get into the next day, it starts off crazy. It starts off kind of like fully crazy. But these two situations right here, they seem a little difficult, but they are really, really not. When you have a square root and a square root on both sides, what you're going to do is square it, both sides. And all it does is get rid of square roots. So now it just becomes 7x minus 8 equals 2x plus 12. So, so simple. Okay, I like when I see these. But the ones that we're going to start off with the next day's notes, they are so hard. So, I mean, not hard, but tedious, a lot of work. But the ones that you see like this, all you're going to do is square both sides, they go away. Now you can just solve these just like you would solve any equation. Okay, I usually do these on the same line. 7x minus 2x is 5x. And 12 plus 8 is 20. Divide by 5. Your x value is equal to 4. So this one is not as hard, and you definitely shouldn't be scared. When you see these ones kind of on the same side, get one on the opposite side. Okay, so get one of the square roots on the other side. So this now becomes the square root of 8u minus 15 equals the square root of 6u minus 3. So now they're on the same, different sides, kind of look like that. Square both, and they go, and the square root goes away. So now, there you go. Have just a regular equation. So subtract 6u from both sides, add 15 on the same line. I would usually do that. Okay, not when I'm first teaching it, but I do it after a while. This becomes 2u equals 15, 14, 13, 12, 12. Divide by 2, and we get our u is equal to 6. Okay. So starting on the next day, it gets right into the more difficult problems like these. But these you can just kind of take a look at, and these are pretty straightforward. Okay. That's the end of day 4, Unit 8, day 4.